For the next several videos, we're going to sort of redo everything we did in sections 3.3 and 3.4 about increasing and decreasing and concave up and concave down and points of inflection, relative extrema. But rather than working with formulas, we're going to try to get our information from some graphs. So I think we're just going to call this kind of little mini section, whatever, analyzing the graphs of f, f prime, and f double prime. And our notes are going to be in a packet that you should have in your in-class stuff. I'm going to make the video pause for a moment. Please make sure you get that packet out. And let's see what we can do. The graph of the first derivative, f prime of a function f, is shown below. So I've got some graph over here. What I need to realize is this is the graph of f prime. It is not my original function f. And I want to figure out various things about my original function f. Where is f increasing? Where does f have a local max or min? And other things like that. We might be tempted to say that f is increasing from -1 to 3, and then 5 to 7, and then 8 on. But that's not the case because this is not the graph of f. I can't just look at where this thing is going up to know where f is going up. This is the graph of f prime. To make sense out of everything we're about to do in this packet, I want you to write 2 notes on the top of your page. 2 bullet points. First one, to use the graph we have, look at the y values. To use the graph we have, look at the y values. To use the graph we have, look at the y values. Second bullet point, and I'm not expecting these to make a whole lot of sense yet. They will as we go through A through D. To use the derivative of the graph we have, look at the slope. Take a moment, copy those down, Edpuzzle's going to stop, and then we'll see how those are going to help us answer every question in this packet. Okay, so I want to know, in letter A, where f is increasing. Well, also in your packet of in-class stuff, you should have a little, I think it's salmon-colored, kind of cheat sheet for all this stuff with all of our definitions of increasing, decreasing, concave up, concave down. Go dig that out for just a moment. F is increasing. Well, what's the definition of f increasing? F is increasing where f prime is positive. Everything here is going to go back to those definitions. I need to find where f prime is positive. But over here, I have the graph of f prime, and I want to know where f prime is positive. According to my first bullet point, to use the graph I have f prime, I want to know about f prime. I'm just going to look at the y values on that graph. F is increasing where f prime is positive. This is f prime. F prime is positive between 2 and 4 because those y values are positive from 2 to 4. And f prime is also positive from 6 until 9. I'm going to say 2, 4, union 6, 9. We're asked to justify this, and our justification is going to be because f prime is positive. And what was I looking at? This is not part of my justification. This is just so I know what's going on. I was looking at the y values on the graph of f prime. Where is f increasing? Well, where f prime is positive. I have the graph of f prime, so I just want to know where I have positive y values on that graph, and we'll say between 2 and 4, and 6 and 9. Next, where does f have a local max or a local min? Local just means relative. Definition of a relative max is where f prime changes from positive to negative, and a relative minimum occurs where f prime changes from negative to positive. take a moment, see if you can figure out where we might have a relative maximum. Where will f have a relative maximum? I'm looking for where f prime is changing from positive to negative, which means I'm looking for where the y values on the graph that I see are changing from positive to negative. I think that's going to happen right over here at x equals 4. Why is that a relative max? Because f prime changes from positive to negative. I realize this might seem redundant. I kind of wrote some information here, but that was really just for me to figure things out. Your explanation really does need to follow your kind of conclusion about where there is a max or a min. Well, how about you tell me where you think there's a relative minimum? I actually think there are two relative minimums. I'm looking for where f prime's changing from negative to positive. I think that's happening over here at x equals 2. F prime is negative before and positive after. And over there at x equals 6, we're going to say x equals 2 and 6. Why? Because f prime changes from negative to positive. There. Next, I'm asked where f is concave up and where it's concave down, and explain. What's the definition of f being concave up? We're concave up, where f double prime is positive. So then concave down is where f double prime is negative. Now, going back to those notes. I have the graph of f prime, and I want information about f double prime. That means I want to use the derivative of the graph that I have. If I have f prime, I want to use f double prime, the derivative of that, which means I'm going to look at my slope values. F double prime is the slope of f single prime. Therefore, a little bit, I am concave up, where f double prime is positive, which means the slope of f prime is positive, which means I believe from -1 up to 3, and then again from 5 to 7, and then again from 8 to 9. 1 to 3, 5 to 7, 8 to 9, because f double prime is positive. And make sure your explanations are never using words like it is positive, it has a positive slope, and anything like that. Your explanations need to refer to f, or f prime, or f double prime. You go write out the answer for concave down. It's really just everything that wasn't included in concave up. We're going to say that we're concave down from 0 to 1, and then 3 to 5, and then 7 to 8, because f double prime is negative there. And I think that takes care of it. See if you can read D and figure out where f has points of inflection and why there are points of inflection. I think you can do this. Points of inflection are where f double prime changes sign, which means I'm looking for where the slope of f prime is changing sign. So where the slope is changing from positive slope to negative slope, or negative slope to positive slope. I'm going to zoom out again so I can see the graph and the answer. I think we've got x equals 1, and 3, and 5, and 7, and 8 as points of inflection, because f double prime changes sign there. The slope of the graph that I'm looking at is changing sign. Now, please notice we can only find x coordinates. We can't find y coordinates of the points of inflection. because I don't have any real information about f. I would need to plug 1 into my function f of x. Well, I've got f prime. There's no way, at least for right now, for us to figure out the value of f of 1 or f of 3. That's coming in a couple units. Take a moment, make sure everything's copied down on this page, and then we'll go on to the next. Okay, one more that we're going to do together, and then you're going to practice a couple things. Take a moment and read problem number 2. So the graph of the second derivative, f double prime of x, is shown. State where f has points of inflection. I know that points of inflection occur where f double prime changes sign. I've got the graph of f double prime. I want to know where f double prime changes sign. Am I looking for where the y values change sign or where the slope changes sign? Because this is f double prime, and I'm looking for information about f double prime, I'm just looking for where the y values are changing sign. This is different than 1D because the graph I'm given was different. In problem 1, I was given the graph of f prime. Here I'm given the graph of f double prime. With that in mind, how about you go find your points of inflection? I'm going to have points of inflection at x equals, let's see, x equals 1. Not x equals 4 because f double prime is positive before that and positive after that. But x equals 7 will count. Why? Because f double prime, the y values on the graph I'm looking at, changes sign there. In the next couple of videos, I think maybe just one, we'll see how I break them up. We're just going to practice with this stuff in a bunch of different contexts.